Hey, hello everyone. Welcome to our channel Physics, where we actually learn physics. So in this lecture, we are gonna look at what is SI unit system. We are gonna learn, we are gonna see each and every detail about SI unit system. What is it? Okay, who made this, who brought this into existence, when it was developed, okay, what is there in it, etc, etc. So all the details about SI unit system we will see in this lecture. Okay, so let's start with our lecture and let's see all the details about this unit system, that is SI unit system. Okay, so before we exactly go into SI unit system, first of all, okay, let's try to understand few concepts, few terms over here, and then we will move to SI system. So as we all know that there are huge number of physical quantities, huge number, okay, that we actually use in our daily life, or you can say in science researches. Like we use mass, we use length, we use time, we use current, we use temperatures, we use energy, we use force, momentum, angular momentum, linear momentum, okay, torque, moment of inertia, and there are many such like kinetic energy, potential energy, electric field, magnetic field, okay, and what more, I mean, there are huge number of such physical quantities that we come across in physics or in science especially, we can say. Okay, so now if you look at all these physical quantities carefully, okay, if you look at all these physical quantities carefully, you will find out that there is a pattern over here. Okay, you will find out that all these physical quantities are actually categorized, okay, are actually categorized into two main types. Okay, you will find out that they are categorized into two main types. Okay, let's see what are those two types. You will find out that there are few quantities which are dependent on other physical quantities, okay, which are dependent on other physical quantities. Okay, there are few physical quantities which are dependent on other physical quantities. When I say dependent, okay, when I say dependent, I mean here that to express this quantity we require other physical quantities, or this quantity can be expressed in terms of other physical quantities. That is what we mean when we say that it is dependent. For example, I will give you, see, I'm saying here some are dependent. So I will give you some example of dependent physical quantities, like force. Okay, force is equal to mass into acceleration. So now you can see that force is a physical quantity and it is expressed in terms of mass, acceleration. Again, if you look at this acceleration is nothing but change in velocity upon the time required. So again, you can see acceleration is also a dependent physical quantity, isn't it? I mean, it can be expressed in terms of velocity and time. Now if you look at this velocity also, this velocity is again displacement upon time. Again, you can see that this velocity is dependent on displacement and time. That means distance and time, isn't it? So that means all these physical quantities are dependent physical quantities. More examples can be there, like momentum. Momentum is mass times velocity, isn't it? Momentum is mass times velocity. Then there is you can take example of like torque, okay, that you will learn. Okay, torque is again R into F, okay, force. Exact equation will be learned in the actual chapter, but you can see again it is a representation of torque. We can see here that this is dependent on R and F again. So there are many such examples where you will find out that these physical quantities are dependent on other physical quantities. Okay, but you will observe that there are some quantities which are completely independent of other physical quantities. Completely independent. Like you can see here itself, mass. Look at mass. Okay, this mass. Okay, I will write here mass. You can say length. You can also see time. Okay, see, these are completely independent quantities. They don't depend on anything, isn't it? They don't depend. Like you can't say really here that mass can be expressed in terms of length. Like I cannot say 2 kg is equal to 5 meters. I cannot say like that. This is completely wrong. Okay, this is completely wrong. We cannot say. Even we cannot express length in terms of time. Okay, we cannot express length in terms of, we cannot say here that 10 meters is equal to, let's say, 100 seconds. We cannot say that, isn't it? Can we? Definitely no. How can we do that? Isn't it? Can you really say 10 meters is 20 seconds or 20 seconds is, let's say, 1 kg? We cannot do that. So you can see here that these quantities are completely independent of other such kind of a physical quantities. Okay, they don't depend on other physical quantities. In fact, other physical quantities are dependent on them, like these, and there are many more. Okay, so in this way we have two categories. One is those which are completely independent on other physical quantities. Okay, and the other one is those which are dependent on other physical quantities. Okay, those which are dependent on other physical quantities. So here I have just named here a few, that is mass, length, time. I am saying here that these are, completely independent. Here there are many actually. You will find out in your book, almost everything, almost every physical quantity is dependent quantity. It depends on lots of other physical quantities. I mean, it can be expressed in terms of other physical quantities. So there are huge number of such quantities, but there are very few actually, very few independent quantities. So we will see that which are the independent quantities. But here the main thing is these independent and these dependent have been given some name. They have been given some name. So these quantities, okay, these quantities, the physical quantities which are completely independent of other physical quantities and which cannot be described or expressed in terms of other physical quantities are called as fundamental physical quantities. So that is the name given to it. Okay, these are called as fundamental physical quantities. Okay, I will write here fundamental physical quantities. Okay, so I will repeat here that the physical quantities which are completely independent of other physical quantities and which cannot be described or expressed in terms of other physical quantities are called as the fundamental physical quantities. Okay, and let's go here, dependent. So the physical quantities, okay, which are dependent, okay, the physical quantities which are dependent on other physical quantities and which can be expressed, okay, which can be expressed in terms of other physical quantities, like we have seen here, are called as derived physical quantities. Okay, I will repeat here. The physical quantities which are dependent on other physical quantities and which can be expressed in terms of other physical quantities, okay, are called as derived physical quantities. So I will write here derived physical quantities. Okay, so you can see the definition on the screen, okay, for these two quantities. Okay, so in this way we have these quantities. Now in fundamental, this section actually, there will be some fundamental physical quantities, like I have said here, mass, length, time. There are more, I will tell you later. Okay, so these quantities will have some units also, like this has kg, length will have meters, this time has second. Okay, so fundamental physical quantities have some units. Okay, since these quantities are fundamental, that is why the units, okay, the units used for the measurement of fundamental physical quantities are called as fundamental units. Okay, they are called as fundamental units. What? The units used for the measurement of fundamental physical quantities are called as fundamental units. Okay, so I will write here fundamental units. Okay, you can see the definition on the screen. Okay, then over here, in case of a derived physical quantity, so derived physical quantities will also have some units, isn't it? Like if I talk about this force, the unit of force is Newton. Okay, unit of force is Newton. So since these quantities are derived physical quantities, these units are also derived units. Okay, so we'll have another concept called as derived units. Okay, so the units used for the measurement of derived physical quantity, okay, the units used to represent derived physical quantities are called as derived units. Okay, so that can be the basic definition for these. Okay, you can see the definitions again on the screen. Okay, so this is the categorization. Okay, this is the categorization of the physical quantities. Okay, that is fundamental and derived quantities. Okay, now the main question arises over here. I have said that there are some fundamental physical quantities, okay, and other physical quantities can be expressed in terms of these physical quantities, these fundamental quantities, isn't it? Other physical quantities can be expressed in terms of the fundamental physical quantities. So if I have to express other quantities in terms of these fundamental quantities, then first of all I have to decide which are the fundamental physical quantities of this nature. I have to first decide, isn't it? Otherwise I cannot express any other physical quantity in terms of fundamental quantity. Okay, so first of all we have to decide actually which are the most basic, which are the most fundamental physical quantities of nature. Okay, now the question that arises is, who decides? Who has the rights, isn't it? Who has the rights to decide all these things? The fundamental, this derived, who does that? Okay, so there is an answer to this. There is a scientific body, there is a committee, okay, which consists of a team of scientists actually, and these scientists are from all over the world. Okay, so there is a team, okay, consisting of scientists from all over the world, which has been given the authority, which has been given the rights to actually decide the physical quantities, their units and their definitions. Okay, there is a committee which has the rights to decide which are the fundamental quantities, which are the derived quantities. They can also decide what can be their units and what can be the definition for that particular unit. Okay, so there is a committee, and that committee is known as CGPM. Okay, CGPM, we have seen this in the previous video exactly. Okay, CGPM is nothing but Conference Generale des Poids et Mesures. Okay, Conference Generale des Poids et Mesures. Okay, basically this is nothing but General Conference on Weights and Measures. Okay, we have seen that actually in the previous video. Okay, so this committee has got all the rights, all the authority to actually control, to actually decide, okay, these unit systems. Okay, these unit system, they can actually decide what is fundamental, what is derived, what can be the unit, what can be the definition for that unit, etc, etc. Okay, so they have got all the authorities, and whatever decisions these people make, those decisions are internationally accepted. Every country has to accept their rules, their decisions. Okay, because it's not just about the decisions. Okay, the decisions are actually made on the basis of research, on the basis of new scientific research that goes. Okay, it's actually a scientific committee. I mean, it consists of, you know, experts from all the fields of science, from all over the world, who are actually into research, who actually do some research. Okay, so they have the knowledge of everything, they know what research is going on. Okay, and on the basis of new research, they may come across with some new definitions for a particular unit. Okay, so that's why whatever they decide, that is final, and that is going to be used by each and every country. Okay, so that is nothing but CGPM. Now CGPM conducts its meetings in, you know, you can say every 4 or 5 years, and in every meeting some changes are actually made. Okay, some changes are made in the definitions of the units, or maybe some new unit systems are introduced. So one such meeting was actually conducted in 1971, okay, which is considered to be one of the historic meetings, okay, of CGPM. Okay, now in this meeting, or in this conference, this team or this committee actually introduced a new system of units. Okay, a system of units which has international acceptance. Okay, which has international acceptance. That means every country has to use the same unit system. Okay, so they introduced a new system of units, and this system of units, okay, is known as the SI unit system, or SI system of units. Okay, this is known as the SI system of units. Okay, SI means what? It's actually a abbreviation for Systemi Internationally. Okay, it's a Systemi Internationally D units. Okay, Systemi Internationally D units. I will just clean this up, okay, so that I can write here. So in 1971, CGPM introduced a new system of units, and it is called as the SI unit system, or SI system of units. Okay, basically SI is an abbreviation for Systemi Internationally. Okay, Systemi Internationally D units. Okay, so again a French name. Okay, Systemi Internationally D units. So SI is nothing but Systemi Internationally, and that's D units. So it's, in English we can call this as International System of Units. Okay, International System of Units. So this is a system which was introduced by CGPM in 1971, and in this unit system, CGPM actually recommended that there should be only 7 fundamental physical quantities. Okay, they recommended that there should be only 7 fundamental physical quantities, and they said that all other physical quantities can be represented in terms of these 7 fundamental quantities. Okay, so they have actually given a list of 7 fundamental quantities, okay, with their units and their symbols. Okay, and now these quantities are actually used as fundamental quantities all over the world. Okay, so this is internationally accepted system of units. Every country uses the same. So now we will see what are those quantities that are given in this system of units. Okay, so these 7 fundamental physical quantities are as follows. I will write here, okay, for you. So the first physical quantity would be nothing but, you can say, the length. Okay, length will have a unit of meter, as we know, and its symbol is small m. Okay, so this is length. Then second physical quantity is mass. Okay, the fundamental quantity, mass. It has a unit of kilogram. Okay, kilogram, and it has a symbol of kg. Okay, next, the third one is time. Okay, third one is time, and definitely it has a units of second. Okay, then the symbol for this is small s. Okay, symbol for this is small s. Then fourth one is nothing but the electric current. Okay, the electric current. Okay, the unit for this is ampere. Okay, ampere, and its symbol is capital A. Okay, now the next one is fifth one, that is the thermodynamic temperature. Okay, the thermodynamic temperature. Okay, it has unit of Kelvin. Okay, and its symbol is capital K. Okay, then the next one is sixth one, that is the amount of substance. Okay, amount of substance, and it has a unit of mole, and it is having a symbol MOL. Okay, mole. Now the last one is nothing but the luminous intensity. Okay, the luminous intensity. Okay, and then it has a unit of candela. Okay, and it is written as CD. Okay, candela. Okay, so that is the SI system for us. Okay, these are the fundamental physical quantities that are defined in SI system: length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Okay, and here you can see the units and their symbols. Okay, so these are the 7 fundamental physical quantities. Now apart from these 7 quantities, there are 2 more supplementary quantities that are defined in the SI system, and these quantities are, one is the plane angle. Okay, the plane angle, and the second is the solid angle. Okay, I will just give you an overview. Okay, you can represent this by theta and here omega. Okay, that is the we can say a variable that is used. Okay, a symbol that is used: plane angle and solid angle. So plane angle we all know. Suppose we have a line and with a point, the angle that is subtended. Okay, let's say we have a line AB over here, and the angle subtended at a point is called as a plane angle, angle subtended by a line. And solid angle is different. It's actually a 2-dimensional angle. Okay, something like this. Suppose you have some area, let's say something like this. You have some area. Okay, and suppose this is a point, and let's say this point subtends certain angle. You can see it's a three-dimensional. It's actually a two-dimensional. See what I have done from the edges of this. Okay, from the edges of this area, I have drawn some lines. Okay, with this point. Okay, with this point over here, O, let's say. Okay, and this area is, let's say, some area A. Okay, so this angle that is subtended over here in between, that is called as the solid angle. Okay, omega. That is called as a solid angle actually. Okay, I will talk about these two specifically in the next lecture. Okay, in details how it is defined. Okay, the unit of this is nothing but radians. Okay, unit of this is radian, and here the unit is steradian. Okay, symbol for this would be, rad, and over here it will be SR, that is steradian. Okay, so these are the two supplementary quantities that are defined, plane angle and solid angle. Okay, so I hope this is clear to all of you. What is SI system? Why do we require it? What is its place in the scientific research? Okay, so I hope everything is clear. It's very simple. It's not that hard. It's not really a rocket science. Okay, so I hope all these quantities, okay, will be remembered by you all. Okay, you know all these 7 quantities. Okay, you know these units. You also know these two. Okay, I hope so. Okay, if you have any doubts regarding all these things, you can ask me in the comment section. Okay, but I hope you don't ask me anything. I hope everything is clear over here. But if you ask, I will definitely answer. Okay, so thank you so much for listening. Thank you so much for watching this lecture. Okay, so in the next video, we are also gonna see about these two, and we'll see some more things in this whole playlist about this chapter. Okay, so again, thank you. Okay, so I will see you in the next lecture. Thank you so much. Bye bye. Have a nice day.